problem. Okay, last time we did this problem. We integrated a certain vector field over the flat surface. And what was that vector field? And we integrated over 1.
We integrated over 0, 0, y.
0, 0, y. The curl of that. Beta is equal to xyz going to xyz 0, 0, y from R3 to R3 cross R3. The notes will not have that. I think we integrated curl of that over the, we integrated the vector field or the curl of the vector field. May I have a look at the notes? Let me see. Yes, that is what the vector field was. But the question is whether we, what was it that we,
Because I remember I rewatched the video following the notes.
No, but this is the, no, this is the normal. No, well, unless I have that, okay, so I think we integrated curl of beta over S. And then we have to integrate beta along 1, 2, and 3. And I finished 1 because that's the boundary. And note that we must always traverse the boundary in such a way that the area lies to the left. We did 1 and we need to do 2 and 3, add the 3 together and get the same result. That is something that I would like to finish, but I can't finish it unless I have the remaining pieces. Yeah. Surface integral of curl beta. And how much did it turn out to be? Square root of 3 over 2 or something like this. Line integral, yes, line integral of beta d sigma is what we have to finish. Yeah, so curl of beta turns out to be how much? 1, 1, 0?
1, 0, 0.
Okay, curl of beta is equal to 1, 0, 0. Yes, surface integral of curl of beta. Oh.
And that curl of beta
Sorry, just a moment.
composed with sigma.
Yeah.
It just turns out as 1, 0, 0 because we have no.
Yeah, no, just a moment. Let me write this down. Curl of beta is equal to 1, 0, 0.
Yeah.
Okay, and surface integral. No, this is not what we need to do. Surface integral should be of, yes, surface integral. So that's SI. A surface integral of curl of beta sigma n sigma is equal to how much? That I calculated? Yes, I must have calculated it. That's square root of 3 over 2. And then line integral of
think we started doing something else.
No. We didn't go. You see, 1, 2, 3. I think I computed the line integral. Yes, that is fine. Where's the computation of the line integral?
Yeah, this is the end. Almost.
Yeah, but I did compute the line integral. Yes. Line integral of beta 1 pi is the parameterization is equal to how much? That's the question. Line integral of beta, it should be, yeah. Is equal to 0. Along 1, it is 0. Okay, so that's the end. Okay, so we have to compute the line integral of beta along 2 with whatever parameterization. Now, 2 is which one? 2 is that one. Okay, so you have to parameterize 2. 2 is this one, this line. So that is x plus y plus z is equal to 1. And this is x-axis, y-axis, z-axis. X is equal to 0. So that means x plus z is equal to 1. So that means it would be, yeah, z is equal to, x is equal to, no, this one, what did I do? Y plus z is equal to 0, sorry.
Oh, yeah.
Y plus z is equal to 0. So it should be x is equal to 0. Y is equal to t, z is equal to 1 minus t. That's just as good as any. Okay, so now I want to look at it once more. I want to put it in exactly the same way. The integral. So I want to look at the last bit.
You want to see the one where you worked out all 3 of them?
No, this integral. Yeah, this integral. Just lower a little bit. Yeah, so this is line, yes, so this is equal to dt over 2, 0, 0, y with the substitution x replaced with 0, y replaced with t, and z replaced with 1 minus t, dot ddt of 0t 1 minus t. Okay, thank you. That should do it. So let's see what that is. The second, yes, the second segment is, yeah, second part piece of the boundary. So this is dt. This gives me just 0, 0 t dot 0, 0 minus 1, 0, 1 minus 1. So this is equal to integral of dt along 2 of 0 plus 0 plus minus t.
Let me turn off the lines for you.
Turn on?
Turn it off.
Why?
Because sometimes you hold it too long and it makes the lines. Right. Shape and line detection off.
Oh, I see what is happening. Okay. So this is equal to minus along 2 dt t. So the t, what are the boundaries? This point corresponds to, so we are going from y is equal to 0 to t is equal, okay. We are going from y is equal to 1. Y is equal to 1 to, so this is 0, 1, 0, and this is 0, 0, 1. So we are going to y is equal to 1 to y is equal to 0. That means t is equal to 1, y is equal to t. So y is equal to 1 implies t is equal to 1. And y is equal to 0 implies t is equal to 0. So we are going, so this is equal to minus t is equal to 1 to t is equal to 0 dtt, which is equal to t is equal to 0 to t is equal to 1 dtt. If you flip the limits, the minus sign disappears. Using the minus sign outside, you flip the limit. So this is half t squared, 1, 0. So this is equal to half, 1 squared minus 0 squared is equal to half. Okay, so now we have to integrate along 3. But this, somewhere I must have made a mistake, because this doesn't seem to me that it's going to work out. So, so line integral of beta along 3 pi. This needs to be calculated. So now I have this line, which I have to integrate. So that's this is the x-axis, z-axis. So that is x plus y plus z is equal to 1. And this is the y-axis. So that is y is equal to 0. So that is x plus z is equal to 1, which means we can take that way. We can take x is equal to t, and that means z is equal to 1 minus t. And or we can take z is equal to t, x is equal to 1 minus t. That is good enough.
Would that be better?
Let's see. It doesn't matter. At z is equal to 1, t is equal to 1. If z is equal to 0, t is equal to 0. So this point is 0, 0, 1. And this point is 1, 0, 0. Okay, so this would be integral over 3 dt beta composed with pi. So that would be 0, 0, y with this substitution, x replaced with 1 minus t, y replaced with 0, z replaced with t. Dot ddt of 1 minus t, 0 t. So that's equal to, this is not going to work out, I can see. So I've made some mistake. So this is 0, 0, 0 dot minus 1, 0, 1. So that is equal to 3 dt 0 plus 0 plus 0. So that's of course equal to dt 3, 0. So that's 0. So integral over 1 plus integral over 2 plus integral over 3 is equal to 0 plus half plus 0 is equal to half, which is not equal to 3 square root of 3 over 2. So somewhere there's a mistake. But since it straddles 2 lectures, I don't know how to find the mistake. Okay, so either the surface integral was worked out incorrectly, or the line integral, some line integral was worked out incorrectly. Okay, I don't see a square root coming over here. So I will work it out at home, where I don't have to go from one thing to another, and then I will tell you. Okay, I want to point out that Stokes' theorem is worked out in the case of, let's see. Oh, so the area of the triangle is square root of 3 over 2. The integral is not square root of 3 over 2. I must have made some mistake. The area of the triangle is square root of 3 over 2? No one remembers, of course. Okay. So if the area of the triangle is square root of 3 over 2, maybe okay, so let me just work this out. Okay, so let me calculate the surface integral. I think I calculated the surface integral, but maybe I didn't. So I will calculate it once more. So this is surface integral, possibly second time. Oop. Second time. So this is x plus y plus z is equal to 1. And we took the parameterization. The parameterization is certainly calculated. X is equal to t, y is equal to s. Sorry, x is equal to s. Y is equal to t and z is equal to 1 minus s minus t. And we have to integrate the curl. The curl of 0, 0, y is equal to, somehow I think I calculated that. This is the determinant E1, E2, E3, del x, del y, del z, 0, 0, y. So this is equal to, this I've calculated before, so we can do this quickly. E1 gives me 1 minus 0, so 1, 0, 0. So E2 is 0, E3 is also 0. Yeah, and now I have to and let's see. The normal, okay, del s sigma cross del t of sigma, which is worked in the notes, page 20, also done last time. That turns out to be equal to, so this is done. This turns out to be equal to 1, 1, 1. 1, 1, 1. So surface integral of curl of beta sigma n sigma. So this is equal to ds dt curl of beta composed with sigma st dot del s sigma cross del s t. Okay, now curl of beta with x replaced with s, y replaced with t, z replaced with 1 minus s minus t is equal to, what was curl of beta? 1, 0, 0. Is equal to 1, 0, 0. So the curl of beta is a constant. Therefore, that in the substitution does not change anything. Okay, so that means this integral is equal to integral over ds dt, and this is 100.111. So this is equal to ds dt times 1. No, so ds dt times 1, the integral is actually the area. So that's why I wrote that equal to, I did calculate that, that's square root of 3 over 2. That's the area of the triangle. But where? It's not what we want. So there is some mistake somewhere.
Del del S of S and del del T of S.
Sigma, del del S of sigma cross del del T of sigma. Yeah, no, but why am I getting the area with this? Because the dot product is turning out to be.
Go back up
Yeah.
to where it starts.
Yes.
Del del S of sigma drop del del S of T.
No, not T of sigma.
Oh.
Yeah.
And maybe that's where it's wrong.
No, that's not where it is wrong, because the area turned out to be completely correct and there was nothing wrong over there. So there is somewhere where I've made a mistake in this one, and which I don't quite understand where, because ds dt, I also don't understand why the integral with ds dt of this one, it is definitely the area, there's no doubt about that. But how, I don't remember how I got the square root of 3 last time. Square root of 3 came.
It was the area of
The triangle, yes, it's the area of the triangle. And
no.
the area of the triangle is square root. Yeah, but
If it was the square root of 1/4 squared minus 1 plus 1/4 squared plus 1 squared. I think.
in the square root, I don't see now where the square root came from. Okay, but it is impossible to find a mistake if the mistake is in a previous lecture. So my proposal is that we forget this problem, but let's do a different problem. Okay, so I don't know why these two didn't turn out to be equal. There is obviously somewhere I must have made a mistake, but I will go home and calculate and then send you the calculation. Instead, what I want to propose to do, surface area is square root of 3 over 2, and this is exactly what we are getting. Square root of ds dt square root of 3. Why? Oh, square root of 3 over 2 came from the. Yes, now I understand. No, it will not be, sorry. This integral will not be square root of 3 over 2. I will calculate it again. So this is, first we integrate over okay. So dt, t going from 0 to 1 minus s. And then ds goes from 0 to 1. Now I understand why it will not give you the, so this is not the surface area, sorry. So this integral needs to be carried out. So this is equal to ds 0 to 1. This is 1 minus, sorry, t 1 minus s 0. So this is equal to ds 0 to 1 1 minus s minus 0. So this is equal to 0 to 1 ds 1 minus s. So this is equal to ds 0 to 1 1 minus 0 to 1 s ds s. So this is equal to 1 minus half s squared. This is 0 to 1, sorry, s between 1 and 0. Minus half s squared between 1 and 0. So this is equal to 1 minus 0 minus half 1 squared minus 0 squared. So this is equal to 1 minus half times 1 is equal to 1 minus half is equal to half, which is exactly right. Okay, so I know the mistake that I made. So I'm very happy now. So where was the mistake? The mistake was that I claimed that ds dt 1 is the surface area. That is wrong. Because ds dt 1 is not the surface area, it's the area of the triangle at the base. This surface area I'm quite amazed that I managed to find a mistake from that I made in the previous lecture. This area is ds dt according to the formula that we developed, ds dt times square root of 3. This integral over the lower triangle. Whereas ds dt 1 over s, which is the lower triangle, this one is simply the area of the lower triangle, which is half. Because its base is half, height is 1. Okay, so I wrote down square root of 3 over 2 without calculating last time because we were almost at the end. That's where the mistake, I didn't calculate it. It needed a lot of motion for it to turn on. Okay, I will repeat again where the mistake was. I did not calculate the last surface integral of curl over of beta. I just said immediately that it is equal to the area. It is equal to the area, but not of the slanted triangle, but of the base triangle. And the area of the base triangle is half, not square root of 3 over 2. Okay, that's the mistake that I made. I just calculated it completely. Okay, so it works out. It's a problem that I made up. Not scalar field, it's a vector field. Yeah.
What does it mean?
0, 0, y? It's a vector field. That means at each point there's a vector. So there's some sort of a flow. So the curl of the vector field tells you how quickly the flow, it has whirlpools. So let's see.
So what does the y change? Like, how does it change our problem?
Okay. How does the vector field change is what you want to know.
Maybe.
Okay.
Reason
Okay. So suppose this is a river. Suppose you have a toroidal aquarium. Okay. I've never seen a toroidal aquarium, but I'm sure it can be built. So this is a toroidal aquarium. Okay. And in order to create the impression to the fish that they're in a river, you have attached it to a motor that makes the water move. Okay. Or you can actually mechanically move the torus. That would also cause the water to move. Okay. So there's a flow in there. Clear? So a vector field tells you how fast the water is flowing at each point. So at each point you have a vector. That vector tells you how fast the water is moving. Okay? So for instance, if you have a bathtub, and there's a faucet over here, the water drains from there. The water here circulates. If the faucet is below the level of the water, over here near the tap, the divergence would be non-negative. It will be positive actually, because water is flowing in. It's a source of water. Near the hole where the water drains, let's put the hole on this side, where the water drains, the divergence will be negative because the water is going away. So it's a sink of water. But it turns as it goes out. You can think of a liquid flowing, then the triangle is immersed in that.
What I'm confused about is that why is the third position the LZ?
Yeah, no. The triangle is, let's say, a mesh. It's like a fisherman's net. So the boundary is made of metal. Inside there's a mesh. And this is immersed in a liquid where the flow at every point is given by the vector 0, 0, y. So the surface integral of the curl tells you the curl gives you another flow that measures the turns. The flow going through the flow of the turns going through the mesh, that is what is measured.
How do we find the area?
No, the area is this, of course, because suppose you have a mesh and things are flowing past, but the speed at different points are different.
Yeah, but we only know that.
No, we know at every point what the speed is. That's what the vector field gives you. The vector field attaches to each point a vector. So let's take the vector field. Let's consider a two-dimensional flow. That means it's water flowing along a surface. You have splashed water along the floor of the bathtub. Okay, at every point, let's say the vector field is beta sending xy to xy, comma yx from R2 to R2 cross R2. How can we picture this? So, well, let's say at the point 1, 1. What is the vector field at the point beta of 1, 1 is equal to 1, 1, 1, 1. So at the point 1, 1, the velocity is this way. That's 1, 1. The velocity is whose components are both 1. What happens at the point 1, 2? So this is equal to 1, 2, 2, 1. What does the vector 2, 1 look like? Well, I can draw it here. 2 in this direction, 1 in this direction. It's this way. So at the point 1, 2, 1, 1, 2, the vector looks this way. It's longer, so the flow at different points is different. So the surface integral of a vector field gives you the flow across a certain surface. That's what it measures.
I understand the flow thing that you're talking.
Yeah, but if I integrate the constant vector field 1, that gives you the surface area.
Integrate.
The constant scalar field. Okay, if you have a surface, it's much simpler. If you want to find this length, and if you want to use integration, what do you do?
So integral from the start starting point to the ending point.
of dx, this is x-axis,
Yeah.
y of x.
Well, because that's what's changing when I'm moving to y.
I understand, but is x, we are integrating the function 1, right? The constant function 1, because what we are finding effectively is the area under this curve. But the area under this curve, if this is equal to 1, is actually the length.
Not fitting in my head at all.
Okay, let's integrate from a to b. So that is,
Okay, I understood why it's 1.
yeah, but if you integrate, what do you get? You get x between b and a, which is equal to b minus a, which is equal to the length.
Yeah.
But integral of dx of 1 is actually this area, because we are integrating the function 1. It gives you the area under the curve. Suppose this is f. A to b, integral from a to b dx. Wait. What is it? So first what does this give you? This is y is equal to phi of x. Integral of phi of x dx from a to b, it gives you the area under this curve, right? So if I write area under curve, if I write, you agree that this length is b minus a, if this is a and this is b.
Yeah.
Okay? This is a, this is b, right? So if I integrate the constant function 1 from a to b, that's the integral of dx.
So we're only looking at how it changes on the S nothing.
Is
So
changed.
It's the area.
Yes, it is the area numerically is equal to the length.
So what is the height?
1. Then it will get twice the length. So we can't integrate 2, we integrate 1. So to find the length, we are pretending that there's a function of constant height 1.
Pretend.
Yeah.
So in our triangle problem, how does that work in our triangle? Because we have.
So we multiply the elementary surface area with the unit normal. That's the norm of del S of sigma cross del T of sigma. Yeah. That is exactly what we are doing here. The unit normal over here is this.
In my head, I'm thinking that what we're measuring then is the change in y.
You know, where are we measuring the change in y?
Well, how I'm imagining it is since we have the 0, 0, y.
Yeah. No, 0, 0, y tells you at the points x, y, z. So let's say I am going to the point 1, 2, 3. 1, 2, 3. What's the vector field over here? What's its value? Let me write the vector field. Beta of x, y, z is defined to be x, y, z, comma, 0, 0, y from R3 to R3 cross R3. Okay? So what is beta of 1, 2, 3? Beta of 1, 2, 3 is 1, 2, 3, 0, 0, 2, right? At the point x, y, z, we have 0, 0, y. So at the point 1, 2, 3, we have 0, 0, 2. So that means at this point, the speed of the flow or the velocity of the flow is 0, 0, 2. What does 0, 0, 2 look like? 0, 0, 2, the x component is 0, the y component is 0, the z component is 2. So the vector field looks like this. So this flow is everywhere vertical.
To think of what we're doing in the triangle problem.
Yeah, in the triangle problem, we are given a vector field. So given no speed, this velocity. Yeah. Yeah, at every point. So if the points have different y's, then they have different velocities of the flow. So there's a liquid flowing. So let's say the liquid is flowing in some way.
And can you use that in the same way that we would find the length of that line segment?
Yeah. The area is the integral of the norm of the normal, unit normal, the norm of the normal over the of this is the surface integral of the norm, normal of the norm of the normal. Yeah, of the norm of the normal. That means we have this at every point we have erected the something of height 1, which changes in direction from one point to another.
We don't understand it.
For the images to form inside the head. Okay, let's do another example. So this time I will cheat because you have printed the notes out. So let's see what example I worked out. I think something with a circle. Yes. I cheated last time also, and I will cheat. I should do something that is not in the notes.
Like paraboloid.
A paraboloid, okay.
Yeah, with the
circular. Okay. No, but this is not on the exam. Okay, so this.
Have a torus, have a circular cap, a spherical cap with a base, with a circular base.
Okay, so we will now. Okay, so this is a paraboloid opening downwards. Now, how am I going to write this down? So x, y, z. If this is the z-axis and this is the x-axis, and if this is the paraboloid that I want to consider, that will be so this will be 1 minus z first of all, let me see if this is correct. 1 minus z is equal to x squared plus y squared. Is that correct? If this point, I want to make this point 0, 0, 0, 1. And if z is equal to 0 in the xy plane, I want the equation to be x squared plus y squared is equal to 1, which is true here. The only thing is that z is equal to 1 minus x squared minus y squared, which means x and y have to be less than 1, which is true. Right? If x and y, x squared and y squared is equal to both 0, which is at this point, z is equal to 1.
So the z equals 1, that's like the starting point.
Z is equal to 1 is the
That's
top. Yeah.
And minus x and minus y squared is if the parabola is opening
Yeah,
down.
opening downwards, yes.
So yeah, it makes sense.
So this means, let me write this down properly. So x squared plus y squared plus z minus 1 is equal to 0. So this area S, or sigma, I don't even remember how it was called in the notes. Yes, the definition is in the notes. Oh, it's a sigma. Okay. Sigma is defined to be the set of x, y, z in R3 such that x squared plus y squared plus z minus 1. I want this to be less than equal to 0. And z is bigger than equal to 0. But no restrictions on x and y. X and y could be positive or negative. Okay. Okay, so now, this is sort of a paraboloidal cap on whose rim is, yes, so this is sigma. Okay. So now let's take some vector field which I want to integrate with this. So what vector field shall we take? Beta is equal to xyz going to what? xyz, comma. Shall we take the same one as we did before, or something else?
0 x 0
0xy. Okay. That may or may not have a the curl may vanish. That's what I'm saying. Okay, that's okay. The curl may vanish. Let's just try. If the curl is 0, then the line integral will be 0. That is fine. Okay. 0xy. So now let's see. So curl of beta, which we have to calculate in any case, is equal to determinant E1, E2, E3, del x, del y, del z. So Ex, Ey, Ez is better to write. 0xy. No, it won't be 0. So I will write on the next page. This is equal to, okay, Ex, del yy minus del z of x. Ey, so it's backwards, del z of 0 minus del x of y. Ez, del x of x minus del y of 0. So this is equal to 1 minus 0, 0 minus 0, 1 minus 0. So that's equal to 1, 0, 1. Okay. Now we have to parameterize this. So the parameterization, look at it carefully. In the parameterization, we want to say the following, that at each point, Z should be given by, if this is ST, sorry. If this point is ST, then Z is 1 minus S squared minus T squared. Because 1 minus Z is equal to X squared plus Y squared. That's the equations of the surface. So Z is equal to 1 minus X squared plus Y squared. Okay? So that means we take the base circle as the parameter space, we integrate over the disk. At each point, we are raising that. So sigma but we shall be actually use a better parameterization. We shall use a better parameterization. We won't take ST, but we will use polar coordinates. We will use polar coordinates. That means we will take X to be R cosine theta, Y to be R sine theta, and Z to be 1 minus X squared minus Y squared is equal to 1 minus R squared cosine squared theta minus R squared sine squared theta, which is equal to 1 minus R squared cosine squared theta plus sine squared theta is equal to 1 minus R squared. 1 is equal to 1 minus R squared. So that means the parameterization sigma is R theta. So we are using cylindrical coordinates essentially. Polar on the XY plane and cylindrical otherwise. So this is equal to R cosine theta, R sine theta, 1 minus R squared. From R goes from 0 to 1, and this is 0 to 2 pi, to sigma. Okay? So now we have to calculate lots of things. Let's see. The definition of the surface integral is on which page? Um, 20, let's see. 19. No, it's not. 20. It was.
It was 20 on the PDF.
Yes. I wonder what.
Is it like the actual definition?
Yeah, I know that. Yeah.
Yeah, in the beginning.
Yeah. Surface integral of beta sigma n small sigma is equal to integral over S ds dt beta composed with sigma st dot del t of sigma cross del s of sigma, del t of sigma. But we don't have sigma and s and t, we have r and theta. Okay, so beta composed with sigma of r theta is equal to, what was beta? I have forgotten. 0xy with x replaced with r cosine theta, y replaced with r sine theta, and z replaced with 1 minus r squared. So that is equal to 0 r cosine theta, r sine theta. Okay, and del r of sigma cross del del theta of sigma. So del del r of, what was it? R cosine theta, R sine theta, 1 minus R squared. Cross del del theta of R cosine theta, R sine theta, 1 minus R squared. So this is equal to cosine theta, sine theta minus 2R cross minus R sine theta, R cosine theta, 0. So this is equal to determinant Ex, Ey, Ez, cosine theta, sine theta minus 2R, minus R sine theta, R cosine theta, 0. So this is equal to sine theta times 0 minus 2R times R cosine theta. Ey minus 2R minus R sine theta, minus 2R minus R sine theta, minus cosine theta times 0. And the last one, R cosine squared theta minus R sine squared theta. So this is equal to 0 plus 2R squared cosine theta, 2R squared sine theta minus 0. And the last one is R cosine squared theta plus R sine squared theta is equal to 2R squared cosine theta, 2R squared sine theta, and R sine squared theta plus sine squared theta. So this is equal to 2R squared cosine theta, 2R squared sine theta, and R. Okay, so the surface integral of theta sigma n sigma is equal to integral over S, which is the lower circle, ds dt, beta composed with sigma r theta dot del del r of sigma cross del del t of sigma. So this is equal to ds dt. So the, oh, sorry, it can't be ds dt. It's dr d theta. Dr d theta. Okay. Yeah. So now dr d theta, beta composed with sigma. Well, how much was that? I have forgotten. 0 r cosine theta, r sine theta, right? Yeah, I think that's what it is. Yeah, 0 r cosine theta, r sine theta. And dot, now this was 2r squared cosine theta, 2r squared cosine theta, 2r squared sine theta, r squared sine theta, and r. Okay, so this is equal to dr d theta, 0 plus 2r cubed sine theta cosine theta plus r squared sine theta. So this is equal to, this is over S. Dr d theta, 2r cubed sine theta cosine theta plus r squared sine theta. So this is equal to S dr d theta, 2r squared sine theta cosine theta plus S 2r cubed, r squared sine theta. So which means in this case, because it's a product of a function of r and the function of theta, I can split the integral. So this would be dr 2r cubed, r is equal to 0 to 1 times theta is equal to 0 to 2 pi d theta sine theta cosine theta plus dr r squared, r is equal to 0 to 1 d theta sine theta, theta is equal to 0 to 2 pi. Okay, so this is equal to let's see, this will be r to the 4th over 4. So this would be 2, r to the 4th over 2 between 1 and 0. This is half sine squared theta. Because cosine theta is d of sine theta, so between 2 pi and 0. Plus 1/3 r cubed between 1 and 0, and this is cosine theta minus cosine theta between 2 pi and 0, right? So that's equal to 1/2 minus 0, half sine squared of 2 pi is equal to 0, minus half times 0, plus 1/3 times cosine of 2 pi is 1. So that is equal to half minus 0, 0 minus 0, plus 1/3 minus 1 plus 1. So that is equal to half times 0 plus 1/3 times 0, which is, okay. So the integral of the vector field over that cap is equal to 0. Now I have to do the line integral around the boundary. Surface integral of the vector field over the cap. Now I have to compute the surface integral of the curl of the vector field. Sorry, the line integral of the curl of the vector field along the boundary. Okay? Okay, so the line integral, first of all, did I compute the curl? What was the curl? 101. The curl was 101, yes. Okay. So now I have to parameterize the, okay, so I have to compute the line integral of the curl of beta how is it written? Oh, along the del sigma, which is the boundary, with the parameterization pi, which we must find out. But the parameterization is easy. Parameterization will be x is equal to r cosine theta, y is equal to r sine theta, and z is equal to 0, because it's in the plane. So we just use polar coordinates. So this is the line integral of, what is the curl of beta? 101. Del sigma is just this del sigma. This is sigma. Okay? Is the circle below. So del sigma pi. So this means I would have, oh, sorry, I have made a mistake. The parameterization will have r is equal to 1 because the radius of the circle is 1. So it's just cosine theta, sine theta. Okay, and z is equal to 0. So now this is equal to Okay, where is the line integral defined? So we defined in terms of t, but we have to use theta. Line integral, where is line integral defined? Yeah, line integral of. So we are going to from 0 to 2 pi, of course. So this would be line integral of 101 del sigma from the initial point to the final point. The initial point would be theta is equal to 0 to theta is equal to 2 pi. Okay, and that is, okay, so now we have to compute. This will be theta is equal to 0 to 2 pi. 101 with x replaced with cosine theta, y replaced with sine theta, z replaced with 0, dot d theta of cosine theta, sine theta, 0. D theta. So this is equal to d theta, theta is equal to 0 to 2 pi, 101 dot d, this is minus sine theta, cosine theta, 0. So this is equal to theta is equal to 0 to 2 pi, d theta minus sine theta plus 0 plus 0. So this is equal to theta is equal to 0 to 2 pi, d theta minus sine theta, which is equal to theta is equal to 2 pi to 0 d theta sine theta. Right? Because I flipped the limits. So this is equal to minus cosine theta between 0 and 2 pi, which is equal to cosine theta between 2 pi and 0, which is equal to cosine of 2 pi minus cosine of 0, which is equal to 1 minus 1 is equal to 0. So which is equal. I didn't cheat today. You made up the problem.
Not more helpful.
Yeah. Oh, but I have never looked at it. It's just because here I can't see what I did previously, even in the same problem. If I write on the board, I will have everything written over here. So I have never in my entire life done in a class things that I did before. I just made up whatever came into my mind and did it. It's a bit dangerous here because it shouldn't be such that the integrals can't be done. But you see, the point is that it doesn't matter which capping surface you choose. If you chose, rather than the paraboloidal thing, if you chose a spherical thing, it would still give you the same answer. Or if you chose the flat, the disk, as the capping surface.
Like why it's 0 from the calculation? Why is it, what is the reason?
In this case, one can sort of understand the reason. Because the vector, it's a symmetric thing. The symmetry is between x and y. It doesn't care whether it is x or y.
Okay.
And so vector field has an xy symmetry. The surface has an xy symmetry. But what happens is that vector field in the first quadrant has positive components. In the fourth quadrant has negative components. So this integral over this over the first quadrant cancels the integral over the fourth quadrant. And similarly, in the second and the fourth quadrant, the signs are precisely the opposite of each other. So it does make sense.
That's why it cancels itself
Yes, yeah.
out. So what if the field was 0, 2 then?
Then it won't work. Then it would be,
And would it be 1?
no, then that we can't say. You have to work it out. Yeah. It could still turn out to be 0, but then there's not an easy explanation. Actually, I think even in that case, it would be 0. But if it was Z, no, if it was Z, X, Y, if it was X, Y, Z, no, not X, Y, Z.
If C wasn't included, then it would be very symmetrical because there is no, it doesn't go.
No. But the symmetry in this case, the symmetry of the object that I'm integrating over is that if it has rotational symmetry. So the vector field somehow has to break the rotational symmetry for it to not quite work out that way. Some sort of thing, yeah. Yeah. But there are other examples worked out in the notes.
I'm having trouble with the exam a little bit because I don't know how to take the derivative and integral of trigonometric functions. It takes me quite a while to get.
No, but you can look them up.
Yeah, try to. So it takes a little bit.
Yeah.
But it's much longer than knowing it already.
Of course. I just wanted to say that there are, I have to write here. So we proved something like this. Integral of beta over the is surface integral of curl of beta. Yes, so that is the divergence of a vector field integrated over a volume is the same as the integral of beta over the boundary of the volume. Yes. Yes. So you compute it in 2 different ways, and the C problem will show that they are. Oh, sorry. This is a line integral. So this is surface integral. Surface integral. This is line integral. This is volume integral. This is surface integral. Okay. And in the plane, if it is, all these are called Stokes theorem, basically. And in the plane, if you take something which a surface integral over the plane, and then you go around the boundary. But yeah, all these are 2 Stokes theorem, basically, various types. So if I have something like this, this is sigma. This is sigma. Boundary of sigma is equal to 3 + 1 + 2. But you always go along the boundary in such a way that the area lies to your left. So the inner one, you have to go in the opposite direction. Okay. Similarly, if you have a volume, this is a sphere from which you've bored 2 holes. And the fans, yes, that kind of thing. But in your case, you have a sphere with the hole in the shape of a donut. Okay, is this clear? Nathan, do the things come back? Are you remembering these things somewhat?
Yeah.
Okay.
You're enjoying it. You're very math. I feel like we got understood a lot.
Okay, but you see, I mean, I saw recent papers. If you have a cylinder and you slice it with a plane, you know that you don't get a circle, but you get some sort of oval thing. Is it an ellipse? This has to be proved. Just any odd oval shape is not an ellipse. An ellipse is a particular shape, which is described as, it must be such that there are two foci and the distance from the sum of the distance from the two foci is a constant. Okay, so not every oval will satisfy that property. So, and that proof is not very straightforward, but it's not trivial. Similarly, if you have an ellipsoid and you slice it with a plane, a cylinder sliced with a plane is solving the equation x squared plus y squared is equal to 1, and the plane can be taken as ax plus by plus cz plus d is equal to 0. If you have an ellipsoid, x squared plus over a squared plus y squared over b squared plus z squared over c squared is equal to 1, and the plane can be taken to be px plus qy plus rz plus s is equal to 0. So if you slice an ellipsoid with a plane, then again it is an oval. But do you know for sure that it is an ellipse? Again, you have to prove. I saw two papers, fairly recent papers actually, which work out the details, and they were published. I am astonished because I can easily think of giving these problems to this class. They were in computer graphics from computer science departments. So I will send those papers to you, and you have the background now to actually read and understand this. So all these things are being used now. And people actually are publishing. So sometimes, yeah, you have I actually didn't know that anyone could publish such a thing. What happens if you have two ellipsoids and you intersect them? So you get some sort of object. I made you, well, I have assigned you, not made you yet, handle the tricylinder. Tricylinder. Yeah, it's called a tricylinder. The tricylinder, what did I ask you to do? To count the number of vertices. We count the number of edges. Then to find the length of each edge. And find the length of each of the faces. Area of each of the faces. And the volume. So now you know everything to work it out. Okay. So, but you will have to work. If Joe, do you have any questions? Joe and Max and Nathan are the true faithfuls now.
I'm good.
Byron has been, yes, Joe, I couldn't hear you.
I said I'm good. I don't have any questions.
Did you understand more or less?
Yeah.
Okay. So this is so I will send you those papers so that you can, you see, I saw people are trying to compute the volume of the intersection of the two ellipsoids in error estimation in statistical analysis. Okay. So these things are being worked out by people who are in mathematics and computer science. Most of them are computer science in computer science departments. I don't know why.
Maybe because you think it's cool because nobody makes them. Makes these papers.
Ah, but
From the
this is very,
mathematics.
yes, because it's, yeah, I'm just a little surprised because I would think nothing of assigning such a problem.
Well, maybe that it is much more difficult to program it.
No, if you don't know the general solutions, then programming will be very difficult. Yes,
So you have to know both how to program it
yes,
into the computer and then how to resolve it.
yeah.
I mean, generally speaking, if you know one, then, it's not too difficult to, implement all of well.
But in this case, the formula, someone has to find the formulas first. And no one bothered. The mathematicians didn't bother to write them down. The mathematicians are not interested in this concrete situation so much. They should be. But anyway, I will send you the papers also so that you can see. Okay. How many people will actually look at them? I do not know. I will send them to the entire STEM people. Okay. But you can't learn this if your objective is to spend the least amount of time on this. So that doesn't work. And those of you who are sort of irritated by the amount of work the solved exams have, once you look at the papers that I will send, you will understand that that work needs to be done, because the papers also do not show all the steps. I forced Mr. Orangebeard to write everything down.
I'm writing in a 3A right now.
Yeah.
It's, very huge.
Yeah. But that's the only way to learn. There's no other way. Some people on 2B skipped the various bits and pieces. But if you've skipped that, you don't get full credit.
In 3A, the 12 exam skips.
Yeah, don't skip anything.
Well, you can't really skip that step because you're not able to continue without it.
Yeah. Okay. My proposal is there. Joe, do you have any questions?
I'm good.
You understood more or less, right?
Yep.
Max, do you have any questions? Okay. Okay. So then my proposal is to stop here. So you go and work on the exam. Okay?